Okay, let us listen now.
Do you know which is the hardest mountain to climb? You would probably say Mount Everest since it's the highest mountain. But that is incorrect. The hardest one is the second highest mountain, K2. Due to the difficulty of its ascent, it's called the Savage Mountain. It is harder to climb K2 because we know that along with height, there are many other factors to consider. Steepness is one of them. For example, let's consider these two mountains. The right one clearly has more altitude, but the left one will be harder to climb as it's steeper. Now let me ask you a question. What do we mean by steepness? For example, consider these two straight lines. Which one is steeper? Here the difference is subtle, but we can see that it's the second one. But can you think of a way to concretely prove that the second one is steeper? It's slope. It's the measure of the steepness of the line. Now look at this curve. What is the slope of this curve? Does it even make sense to ask this? What do you think? In this video, we'll understand what this means. Here, the process of differentiation helps us. Also, we know that such a curve can be represented algebraically by a function between two variables. We will see that this slope is connected to the idea of the derivative of a function. So let's continue with our question. One thing we can clearly see here is that different positions of the curve will have different steepness. We can intuitively see that as we move from the left towards the right along the curve, it gets steeper. So the slope of the curve in general doesn't make sense. So let's focus our attention around this point P. What will be the slope at this point? For this, let me ask you one question. Is the Earth flat or round? You'd probably be laughing because we all know that the Earth is almost round in shape. But notice the surroundings around you. It seems that the Earth is flat. Why is it so? Consider this circle as the representation of the Earth. And let's say you are currently situated here. If we zoom in around this portion of the curved line, we see that it becomes less and less curved. It looks almost like a straight line. So let's say we draw a straight line only intersecting the curve at this point. We can see that the curved line is almost the same as this straight line. We know that this line, which passes through only one point of the curve, is called the tangent line at that point. Take a moment and just observe what we found. This is the most important idea on which calculus is built. A curved line in a very small region around a point on it can be approximated by a straight line. This straight line is the tangent line at this point. So this solves our problem. The slope of the curve at a point will be equal to the slope of the tangent line at that point. And we are familiar with how to find the slope of a straight line. So how do we find the slope of the tangent line at this point? But before answering this question, let's look at why are we so interested in finding the slope. We will continue this in the next part. Previously, we saw what we meant by a function between two variables, x and y. A function tells us how the value of one variable depends on another variable. So if the value of x changes from x0 to x0 plus delta x, then the value of y will also change from y0 to y0 plus delta y. Now look at this ratio, delta y over delta x. It tells us the rate at which the value of y changes in proportion to the change in x. For example, consider these two ratios. As the ratio in the second case is greater, the value of y will change relatively faster here. This rate of change for a function is actually related to the slope of a curve. Let's see how. Let's say the graph of this function is a straight line like this. X naught, y naught is this point, and when the value of x changes by delta x, we reach this point. Now consider the ratio delta y over delta x. We saw earlier that for a straight line, this ratio is the measure of its steepness. So, the rate of change in y with respect to x is equal to the slope of this line. Now we can see that for a straight line, its slope is constant throughout. So its rate of change will also be constant. But what if instead of this, the graph of the function is given by a curved line? The slope at a point tells us the rate of change at that point. We've seen earlier that in a very small region around a point, the curve can be thought of as a straight line. This is the tangent line at this point. So we see that the slope of this line is equal to the rate of change here. But now, we can see that depending on the point on the curve, the slope will change. So this means, depending on the value of the x variable, the rate of change will also vary. Now let's look at an example to understand this. Let's say in this function, y is the distance traveled by an object in motion, and x is the time taken for the distance traveled. Then the rate of change in y with respect to x will be equal to the speed of the object. In the first case, we know that the rate of change is constant. So the speed of the object will be constant throughout its motion. While in the second case, the rate of change is not constant. So here, this rate will tell us the instantaneous speed of the object. For this reason, the rate of change for a function at a particular value of x, x naught is called as the instantaneous rate of change at x naught. So to conclude, a very small portion of a curve around a point can be approximated by the tangent line at that point. The slope of this tangent line tells us the instantaneous rate of change of the function at that point. But how do we find this slope or instantaneous rate of change? Do you remember that in one of our previous videos, we found the instantaneous speed of an object? To find the instantaneous speed, we have to use the process of differentiation. Let's say we want to find the instantaneous speed at this point P, that is at the time instant x naught. For this, we first find the average speed for some time interval delta x. At x naught, the distance covered will be this. And at x naught plus delta x, it will be this. So the average speed in the time interval delta x will be equal to this. For a function, this ratio is called as the average rate of change. Now let's say we draw a straight line between these 2 points. It's called the secant line. We see that the slope of the secant line will be equal to the average speed in the time interval delta x. So we see that the average rate of change between 2 values of x is equal to the slope of the secant line between the corresponding points on the curve. Now what's the next step? How do we find the instantaneous speed from this average speed? For this, we find the average speed in shorter time intervals, that is, as delta x tends to 0. We say that when the limit delta x tends to 0, the average speed approaches the instantaneous speed. This instantaneous speed is the instantaneous rate of change at x naught. Now what happens to this secant line as delta x tends to 0? Let's say we find the average rate of change between points P and Q1, Q2, and so on. We can see that as delta x tends to 0, these points come closer and closer to the point P. So as the limit delta x tends to 0, the secant line will pass through only one point P on the curve. That is, the secant line approaches the tangent line. This is how, using the process of differentiation, we find the instantaneous rate of change of a function or the slope of a tangent line. Now here, instead of writing the instantaneous rate of change in y with respect to x at x0, we say that the derivative of the function at x0 is this. The derivative is usually denoted by the symbol dy by dx. So we saw here that the derivative of the function at a particular value of x is its instantaneous rate of change at that point. In the next lesson, we will further explore the concept of derivatives.
Point property. The derivative of a function at a, how it is defined. Suppose f is a real function and a is a point in its domain, then derivative of f at a is defined by this a. It is a point from the domain of the function, right? F dash a equal to limit h tends to 0 of f of a plus h minus f of a by h. Here f dash a is the derivative of the function at a. Last year I have studied, and this derivative at a is the limit of Newton's ratio. And how do we find the ratio? Here is the difference in the function value. That is f of a plus h. In the previous video, instead of h, we have used delta x. The x is changed from a to a plus h. Then the corresponding function value is f of a plus h minus f of a by h. Last year we have studied this. Dash a is limit h tends to 0 of f of a plus h minus f of a by h. If it is f dash 2, what will be that? F dash 2. That means the derivative of f at 2, where 2 is a point from the domain of the function. F dash 2 matlab, here हमारा f of 2 आएगा. Here we have f of 2 plus h. F of 2 plus h minus f of 2 by h, and as h tends to 0. If it is f dash x, what will be that? Limit h tends to 0, f of x plus h minus f of x by h. Right? So, this much you have studied. This is the previous knowledge. Last year you have studied. Now, again, you look at this limit. The derivative of f at a is a limit. Now, the question arises, this equal to limit h tends to 0 only if the left-hand limit and right-hand limit exist and are equal. Suppose we find the left-hand limit. Left-hand limit means what you will get? Limit h tends to 0 minus of f of a plus h minus f of a by h. That is known as the left-hand derivative of the function at a. It is just like left-hand limit of the function. Here we say it as left-hand derivative of the function at a when h tends to 0 minus. And when limit h tends to 0 plus of this ratio, we call it as right-hand derivative of the function at a. So you can write it as the definition. If one of the limit does not exist, we say that the function is not differentiable at a. Differentiability of a function at a domain. A real function fx is differentiable in its domain if it is differentiable at all points of the domain. It is just like your continuity function. A function f is said to be continuous if it is continuous at every point of its domain. Similarly, a function is differentiable if it is differentiable at all points of its domain. Already we are familiar with this. F dash a means f of a plus h minus f of a by h. F dash x means only this definition you write. Only this f dash x you write. F dash x equal to limit h tends to 0 f of x plus h minus f of x by h. No need of writing all the sentences. You only have to understand. You will be using the limit idea to find the derivative. We have already last year done, but this year you don't expect any question from using first principle. Now this is another notation. Suppose y equal to f of x, then f dash x. You have already learned what is f dash x. F dash x also can be written as d by dx of f of x. It is not divided by. It is not the real number division. It's a simple d by dx for denoting the derivative of the function with respect to x. We say that d by dx means derivative of f of x with respect to x, and can also be written as dy by dx. dy by dx doesn't mean that it's a division. It's a notation we are using, and can also be written as y dash. Y dash, y equal to f of x, then it's y dash. One more symbol we use is y suffix 1, y1. So please write this also throughout, okay? Next one. Some results on differentiability of a function you have to learn now. You have seen that what is the continuity of a function, and ultimately you have to find out, is there any relation between continuity and differentiability. If a function f is differentiable at a point A, then it is also continuous at that point. But the converse may not be true. So in another way, we can say that the differentiability is a much stronger property than continuous. If you take all the differentiable functions as a set, that will be a subset of the set of all continuous functions. Okay. So if you use the Venn diagram sort of thing, you can remember this. The D is a subset of C. D, the set of all differentiable function, is a subset of the set of all continuous function. D subset of C, if you write, it will be easy to remember. Every differentiable function is continuous, but the vice versa, the converse may not be true. Okay, that is now the topic which I am going to tell you. May not be. Only you have to write this thing now. D subset of C. You write that symbol. D subset of C. Set notations you use. Capital D subset of capital C. In right side you can write D equal to set of all differentiable function and C equal to set of all continuous functions. So from that you can make out every element of D is also an element of C. Means every differentiable function is continuous at that point, but the reverse converse, that every continuous function differentiable is not true, or every continuous function may not be differentiable. It is simple example. I'll explain it to you. This is a very important example. Modulus function f of x equal to mod x is continuous at x equal to 0. You know what is the shape of What is the shape of f of x equal to mod x? It is a V shape. We have already seen a lot of GeoGebra graphs. It is a V-shaped graph, and we know that f is continuous at x equal to 0. We have already done it. Only one point we are considering, that is the point 0. Now we will check the continuity at 0 as well as the differentiability of the function at 0. F of n. Now, how to find the differentiability? You see, what is f of 0 plus h? It is modulus 0 plus h. F of 0 is modulus 0. Now, to find the differentiability, you find the left-hand derivative at 0 and right-hand derivative at 0. If both are equal, then we can say that the derivative of the function at x equal to 0 is existing. Okay. Now, sound is coming. See how to find this. Limit h tends to 0 plus f of 0 plus h minus f of 0 by h. That means what? Limit h tends to 0 plus, you write the function f of 0 plus h means f of h. F of h means, you substitute here, okay? So you will get modulus of h and modulus of h. H tends to 0 plus means what? H is greater than 0. When h is greater than 0, what is modulus of h? It is h itself, because you have already learned that is modulus function is having two values, mod h equal to h when h is greater than 0 and mod h equal to minus h when h is less than 0. So on simplification of this, what you will get? H get cancelled and you will get the value as 1. H and h can be cancelled because h is never equal to 0. So that is equal to 1. Now let us find the left-hand derivative. That is, left-hand derivative is limit h tends to 0 minus of f of 0 plus h minus f of 0 by h. And while you substitute here, you just see how to substitute. H tends to 0 minus, that means h is less than 0. Then what is modulus of h? Modulus of h becomes minus h. So modulus of h, modulus when you remove it becomes minus h, and h can be cancelled because h not equal to 0, and here you get the answer as minus 1. It is minus 1. So what does it mean? The left-hand limit is not equal to the right-hand limit. So that means the function is at the top, that every continuous function need not be differentiable. Every continuous function need not be differentiable. Example, f of x equal to mod x is continuous at x equal to 0, but not differentiable at x equal to 0. Continuity, I am not proving it because we have already done it. Now, f is not differentiable, that is proved. So, f of x mod x is not differentiable even though it is continuous. You have already written it. This is a graph. Another thing from the graph, how do we understand that whether it is differentiable or continuous? In the continuity lesson also, we have discussed about, from the graph we can make out whether it is continuous or not. If there is any break in the graph, in many of the cases it is not continuous. And here you can see that there is no break in this curve, so it is continuous. But it is not differentiable at this point. It is what called, it is like a corner type point. Okay, it's a pointed one. When there is a corner type of points comes in the graph, at that point the function is not differentiable. At that point, that is here, this point, there is a corner. And different graphs. And one more thing is that if the curvature changes, then it is not differentiable at that point. One more idea is that suppose you consider the tangent at this point. You can see that the tangent here, it is like this, it is coming, its slope. We have just now we have told about the slope. Here the slope becomes -1, and here if you consider the tangent, it becomes +1. So slope -1 +1, the derivatives at that point can be two derivatives, -1 and +1. One is a left-hand derivative, another is right-hand derivative. Both are not equal, so it is not differentiable. So these are the many ways to find graphically whether a function is differentiable at that point or not. Okay. Next, last year what we have studied, all these rules of derivative, just a quick revision only. U plus or minus v dash. U dash means the derivative. It is u dash plus or minus v dash. U into v dash. That is a product rule. You have studied first function into u into derivative of the second plus second into derivative first. Then you have studied u by v dash. It is v into u dash minus u into v dash by v square. Write this fast. Rules of derivative, which I have already learned. And today evening I will call you and ask questions. Last year, how many formulas of derivatives you have studied? Everything you have to study today itself. Before 5 o'clock, I'll call randomly some children. I will be putting mark. Okay. Previous knowledge should have all the derivative formula you have to study and keep, so that we can start our lesson on composition of functions on Monday. Please recollect all this. It's a quotient rule. The last one is quotient rule. Now we will have a quick revision on the formulas you have studied last year. Y equal to x raised to n implies dy by dx is equal to n x raised to n minus 1. Please write the formula now. Y equal to root x. Then dy by dx is 1 by 2 root x. All this you write down now. Derivative of log x is 1 by x. Derivative of sin x is cos x. And what you have to do now is take last year's textbook and write all the formulas what you have studied last year 11th. Okay. Evening I will call randomly. I will call some of you and will ask a question. So study now today itself after 1 o'clock. 3 hour time I'm giving you. Within that you have to complete all this.